Hi everyone, I'm Christoph, CTO at Graphware. Today I'm going to present some full text search tips and tricks with Neo4j. The reason of this talk is that at first impression, the full text search capabilities in Neo4j can appear very basic, but by actually knowing a bit how full text search engine works and using the graph to make your search queries more relevant and having, of course, a lot of Cypher fun, we can achieve some very decent results for most of the use cases. The agenda for today, I will go over a refresher of the full text search syntax, especially the Lucene syntax, which is the search engine used by Neo4j. We will then go over some relevant search techniques using graphs, and we will finish with some advanced full text search queries. I would probably replace advanced by very fun. All right, so for the first part, for the refresher, I will use a dataset that has been published today, which is the list of the talks during this online conference. And we will go over some basic search queries. So the first thing to do, of course, is to import the data. So we just load the CSV and we'll create talk notes with their title, descriptions, and the speakers. So let's do this. We have 57 talks. The next step is to create a full text search index on those notes. So we will give a name, talks. We will index notes with those labels, here only one, talk. And we will index those properties from the notes, so title, description, and speakers. Once this is done, we can start to search. For searching, we use a dedicated procedure available in Neo4j, which is db index full text query notes, where the first argument is the name of the index, and the second argument is actually the full text search query. Here, we can only use the Lucene simple query syntax, and we will go over some of the syntax specifications during this talk. So here, I will search for all the talks that contain microservices and will return the title, the speakers, and the score. So here, I have the talk, the speakers, and the score. Here, you can see that I added double quotes around my search query. And this is to instruct the query engine to actually use a phrase query and not a term query. To explain you the difference, if I would write my query like this, it will find documents that contain either full or either text in their title or description. We could actually replace this query by full or text. However, it doesn't. In most of the cases, we would like to be able to specify that the sequence of the tokens or the words is important. So we have to enclose the query inside double quotes to instruct the system to make a phrase query. Here, you can see that it changed completely the search result. Let's go further. With the previous queries, we were actually searching in all the fields of the index. If you remember how we created the index, we actually indexed 3 fields, title, descriptions, and speakers. Here, we are not specifying a field, so the query is applied across all the fields. We can specify a specific field during the search. We just specify the name of the field, the column, and the search query. Of course, we are not limited to only one field. We can specify that we want modeling in the title and Luan in the speakers field. Again, even if Luan is not the speaker of this talk, it's because the query treats this query as a find modeling in title or Luan in speakers, or both. So it's equivalent to writing this. Again, we can modify the behavior by writing a and clause instead. So far, we have executed full text search, exact matches. This means that full text or Luan or modeling have to match completely other words in the indexed documents. We can, of course, add a bit of fuzziness or wildcard searches. Here, we will search for talks having a title where there is a word or a token that starts with the string model and then finishes with anything. Great. Now, how can we actually make the search a bit more relevant to our use case? For example, I want to say that I'm searching for talk about machine learning. So I will write description ML and title ML. Of course, I would say that if machine learning is in the title, it should be more important than if it is in the description. We can actually use the operator, the boosting operator here, and an integer or float value to actually boost that if machine learning is in the title, it should increase the score of the returned result. So we can see here that because it is in the title, it boosts the score. Here, it is also in the title, but probably not in the description. So this is why this first result actually has a much higher score, because it is both in the title and in the description. Right now, I'm going to search for the title of the current talk. So the name of my talk is to be or not to be, full text search, tips and tricks. So I will search for to be or not to be. And surprisingly, I have no results. Even though if I would search for a talk without the full text, I can see that I have well the note of my talk. Why this happened? For explaining this, I have to go back to the slides with a bit of history about search engine. So how data is indexed in a search engine? Actually, the text is tokenized. So actually every word or token is represented here as a line and given a number. You can see the number as a sequence number. Then based on those numbers, we store an array of all the documents in which this token or word appear. So here, for the word 0, it appears in document 0, which is mastering highly distributed architecture. The token 6 in is in the documents 1, 2, and 3, etc., etc. But before it is arriving in the index, it goes over a series of filters and analyze. So the first filter that is applied is the HTML character filter that will remove all the HTML tags from the piece of text. So it becomes this without the HTML. Then we have the ASCII character collapsing filter, which will remove or replace the characters having a specific encoding. So here, for example, the Z and the A have a specific encoding. It is removed and replaced by ASCII character. Then it is applied the tokenizer, where it will tokenize, so split the sentence into tokens. Then all those tokens are lowercase. Then we remove stopwords. So we remove the, at, the, in, and then they remove the possessive. So we will remove here the apostrophe and the S from grapher to store only grapher in the index. So at the end, only 1, 2, 3, 4, 5, 6, 7 tokens will be stored and be added also to the post list. This is the default stopwords used for English. So this is the list of stopwords. So if you remember the name of my talk, to be or not to be, well, actually, none of my talk title will be indexed in a search engine by default, because all the title is actually a stopword. This is why we don't find any results. On the other side, when we search, when we make a search query, the query itself is also analyzed and filtered, etc., to match exactly what is in the index. So how can we circumvent this? Is that we can create a custom Lucene analyzer. So it's a very easy to do. So you just create a simple Java class that extends the analyzer, the standard analyzer, but by specifying actually an empty array of stopwords. You can then build this analyzer and just put it into your Neo4j plugins and restart your Neo4j database. And it's then available for you to create a new index. So let's do it. I will remove my current index. I can list the available analyzer. So I have already added my analyzer, which is here. Standard no stopwords. And I can use this as a setting when creating my full text search index. So here, I will recreate the same index, talks, on the talk label, title, description, speaker. I will just specify that I want to use my custom analyzer. If I would issue the same query we did before, we now see that search results are returned from my talk. This is great so far, but at the end of the day, it returns only results that have a similar text. But we're here with a graph, and the graph has a lot of context. I mean, as a user in a network, you have a lot of context in this graph. It would be a shame to not reuse who you are in the network in order to give more insight, to make the search engine work, taking into account who I am in the network. I will switch to another use case of database for this example. So we will use the Neo4j community forum. So in my database, I have all the posts, user, topics, categories, etc. from the community forum. And we will first make a graph query to build the user context, to actually tell the system who I am in the network. And we will then use this context to make search results not only relevant for text similarity, but also based on who the user is in the network. So let's start with this. I will The data is already in the database. We just have to create an index. So in order to see the data, we can see the model here. So we have a company, a user that works for a company, a user that wrote a post that has a link to a URL inside its post. The post is specific to a topic, and the topic belongs to a category. So let's create the index here. I will first create an index for user, so I can search for user. But when I mean search for user is that if I go to the current version of the community forum, if I search for Jan, I have here a couple of suggestions, which to me are not really relevant because I know none of those persons actually. So would it be nice if actually the first results could be the Jan persons that work in the same company than me? It would make much more sense. So let's create the index. And there is a specificity with the current implementation of the full text search is that Neo4j can index only string properties. It means that it cannot index integers or floats or any other thing than a string. So the technique here for making the new search query will be actually to find who are my colleagues, collect their node IDs, and then insert the query that I want to boost users where the ID is in the list of my colleagues. So first, we have to, let's say, set a property ID on the nodes, the user's nodes, that is just a string representation of the Neo4j internal ID, which is a log. We can do this. Now, I will have to actually delete that one. I didn't take the ID into account. So let's create an index for users, for user labels, and we will index the name and the ID properties. Here it's done. So how to make a where in query? Well, the Lucene syntax would be, for example, under parentheses, I write the possibilities of the in. So if we think about IDs, here there would be ID, ID of colleague 1, ID of colleague 2, or ID of colleague 3, etc., etc. So we will actually generate this query string here with epoch. How can we do this? We just use epoch.text.join. We just join strings of a collection with the specified delimiter. So this would return, for example, 1 or 2 or 3. So instead of giving the collection, we will actually retrieve the user that works in the same company than the user. So here I will match myself, who works for a company, and I will find my colleagues. Then I will generate the string based on the collection of my colleague IDs, and I will boost actually the result for Jan search for the Jan that work in the same company than me. Let's introduce this. So if I go here I can see Jan Jacques, and the score is the much higher score. And Jan Jacques is our graph visualization expert at Grapher. Let's go a bit further. We will create a new index for the post. So actually the text that is contained here. in the questions and replies. So we will create the index. Here, I will name the index nodes 19. I will index post nodes. And I will index topic, which is the topic title, text, ID, created at, we will see this later, and user, which is just a normalization of the user node who wrote this post. So we copy actually the relationship into a property on the post node itself. This is because search engines don't have a graph structure, so we have somehow to normalize the documents indexed in the search engine. So my index is created. Let's find another use case for those. So let's say here that if I type full text in the search bar, I would like actually that my own posts are returned first. All right. So how to do this? Well, in the same way as searching for my colleagues, I will search first, based on my context, what are the posts that I have written. I will collect the ID and I will generate the boosting query as we did for the user. This is what the query looks like. So here I match myself what I wrote. I collect the post IDs. I generate the OR, the long OR cipher query string. And then I call the index searching for topic full text ID, the generated OR query for my own post ID. And I return the result. So here we can see that this one is returned still first. It's because I sum the score here. So the post actually is only one here. So here we have two posts, but on each post documents, we have the topic again. So this is why there are a sum to do, but we can avoid the sum and just return the score. Here we can see that my own post is actually boosted more than all the others. All right. Now we speak a bit about the synonyms. So we can use a graph to store actually what words are synonym of what. I mean, here it will not be very complicated. There are multiple ways of doing it. You can use a graph, you can use ConceptNet, you can also use built-in Lucene synonym capabilities, but it is a bit more complex to create. Here we have just a simple example where I created that Lucene is an alias for full text search, and full text search without space is an alias for full text search with space. They're all alias of each other. That means, and it would make sense, that if I search for Lucene or for full text search, the results for full text search or Lucene are returned for the same query. In the same way that searching for graph query language or searching for GQL would know that it should return the same documents. So how to build a synonym query? Well, first, we have to understand that if I would search for two different phrase queries, for example, so here it's 19, and I would search for full text search. Well, I cannot put or clauses inside the first query. So I cannot say full text or full text with space or etc. So I actually have to treat them as distinct search queries. So what I can do is do this, or Lucene, or etc., etc. Of course, it is impossible to build manually, I mean, in a real world scenario. So we can build actually this dynamically with Cypher. So here, I created a small query that, based on the input Lucene, will go over the aliases. Let's write down the query again. We go over the aliases and replace the input inside the query and generate new OR clauses. Going further, we actually have to take the input and regenerate with the parentheses the queries. So this is what this query would return. We can then use this query with the full text engine and query for nodes. So we just say topic and the final query. Final query is the query that has been generated here before. And we can see that searching for Lucene returns documents or nodes that have full text search in their topic title. Earlier we discussed about this created at property. I will come to it right now. So as I said, we can only index strings. So how would we simulate or actually do a decay behavior? So what is a decay behavior is that we will boost the most recent post or topics based on time. So the most recent will be more boosted than the most older post. So to explain this, we have to actually think a bit. So here I will return the timestamp for now, here. And this is the timestamp of now minus 7 days. I will use those two timestamps to actually make a query to make a range query. So we have to transform the created at properties into string timestamps. This is already done on my database, but I can show you actually here. This is converting actually the post dates into millisecond timestamps. So we can see here. So no reason. Oh, here. And what is the syntax, the Lucene syntax for range on strings? Well, it is this. So we here with curly brackets, we say from here to there. So when the created at property field or property is from this timestamp to this timestamp, you boost its results by 10. So I will take this and here. And we can see it works. Of course, we don't want to just say for 1 week. We can say the week before should be boosted by 9, the week before by 8, the week before by 7, etc. So here we can have a lot of fun with Cypher, actually. This is a query for generating buckets of time. So if you think about this query, so the from to, we can generate it with Cypher. So I just go over a range from 10 to 100 with a step of 10, and we generate the buckets. So to give you an example of what it gives, it generates actually the query string for multiple created ads. So we say from last week to now, boost by 10. From the week before to one plus week, boost by 9, etc., until 1. So we can query documents. So we generate the decay query string. We search, for example, for full text, and we add the decay here. So all the created ads. And here, it's actually boosted by type. So you can see similar score are probably from the same bucket, etc., etc. We can, of course, combine all together. So we can actually say boost the post written by my colleagues, but also boost them by decay function or decay samples. So here, I will search for full text. I will boost them by 3 if they are posts written by my colleagues. And then I will boost them again by their time. And this is what it's written. So here, the first result appearing is actually a recent post from my colleague František, which is appearing on here on the Neo4j forum, and is quite recent. It is now time, I mean, this is the end of my talk. It is now time to go over the Hunger Games question. So my questions for to be or not to be full text search tips and tricks. So the easy question is, what type of properties can we index for full text search? So A, all properties, B, only string and integers, C, only strings. Medium level question, how can I index stopwords such that they can be searched? You can or use an analyzer available in Neo4j by default, or B, use a custom analyzer written with Cypher, or C, use a custom analyzer written in Java. And the hard question is, how can you boost a specific field during a query? And ABC, you have to choose between the operator. You have to answer the questions on r.neo4j.com/hungergames. Thanks for joining my talk. I will go over some of the Q&A questions, if there are any.
There are. They should be in the Q&A section. And if anybody else has questions, feel free to post them in the Q&A section.
All right. So I am reading the question, so you should see my screen actually. So Graph created the Neo4j to Elasticsearch plugin. Would you still use Elasticsearch for any case while Neo4j now supports the full index functionality? Yes, of course. So there is Lucene by itself cannot replace, I mean, even if Elasticsearch uses Lucene under the hood, you cannot do with the simple search syntax what you can do with Elasticsearch. So Neo4j is focused on graphs. You can handle quite a lot of use case with the out-of-the-box now full text search implementation. But Elasticsearch is by far one of the top search engine on the market. So it's 2 different use cases actually. But yes, we still use Elasticsearch heavily. And it's Neo4j cannot replace Elastic as of today, and probably is not the goal. You mentioned you can apply the analyzer. Does it apply to all fields, or can you specify an analyzer for each field? So it's a good question. So the analyzer is for all fields. As of today, there is no possibility to use an analyzer different for the whole for different fields in the index. So no, it's not possible to analyze per field. Do we have a good resource for Solr syntax in Cypher queries? So actually, this is not Solr syntax. This is Lucene syntax. So yes, there is a good resource. So if you go to Lucene query syntax here, there is the query parser syntax here. You just have to adapt the version to the Neo4j version that is used, to the Lucene version that is, excuse me, that is used by Neo4j. Okay, site not update Lucene query syntax. But yeah, it didn't change much. I think nothing changed actually. So I can paste this in the chat. Here, no. I cannot, I will paste in the chat, I cannot reply to the question. Yes, so this is the Lucene query syntax. So, but you will find kind of a lot of resources online. So you just type Lucene. No other question, I think.
Somebody just posted in the chat. Someone said thanks. Are there any other questions? Okay, cool.
No, all right.
You guys enjoyed the talk.
I will share the slides and
wait,
the database.
You got a question. We spoke too soon.
Okay. What are the most of use cases for full text search? Well, full search. No, yeah, I mean, the use case you see here, for example, is a good use case for full text search. You can, I mean, yeah, everything is search. I mean, it doesn't make sense to apply full text search on fixed strings, so things that are not fuzzy, I would say, like credit card numbers or phone numbers, IP addresses, for example. This is not the good fit for search, but everything that is text-based makes, and that you have to search, makes search. Of course, you're limited by the current capabilities. So I would say building a full autocomplete engine at top Neo4j as of today is a no-go. So there's a use case again for using Elastic, for example. But yeah, so everything search actually, but it has to be taken with a grain of salt, because as I explained, doing text similarity search today is useless. You want to do relevant search. So you want to use graph to make your results more relevant, actually. There is another question. Do partial matches for, say, a type-ahead widget work in different languages? Yes. So you can use different analyzer based on your languages. But let's say that in Europe, the standard analyzer would work pretty fine. Czech has some specificities for analyzer. Nordic languages have some specificities for analyzer. But there is a big list of analyzer already available with Neo4j. So yes, you can do type ahead. Yes. And there was a question if I will post my queries, etc. Yes, I will share on the community forum here. Actually, the database, the slides, and all the queries that I used today in the Neo4j browser. All right, I think that's good. Thanks for joining me. Thank you very much. Yes, don't hesitate to visit our website, goafare.com. We have some big blog about Neo4j and some blog posts about full text search with Neo4j. And enjoy the rest of this conference. Bye-bye.